Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on combinations. So by the end of this video, hopefully you can understand this notation, NCR, for combinations, and also calculate the number of combinations. So what we're looking at is a way that we can calculate how many different ways I can pick R objects from a group of N objects. Probably doesn't make a lot of sense. Now, let's start with an example. So this is the kind of question for which combinations would help. So let's say we have 5 boys here: Aaron, Brad, Cameron, Daniel, Ethan. So there's 5 tennis players, and we're going to pick a team of 2. We're going to pick 2 out of these 5. How many different ways could I do this? Okay, so I could easily count this because there's not many of them. So I could have Aaron and Brad. I could have Aaron and Cameron, Aaron and Daniel, Aaron and Ethan, and so on. I could have Brad and Cameron, Brad and Daniel, and so on. So these are all the possible combinations. There are 10 possible combinations. There are 10 different ways that I could pick 2 out of these 5 gentlemen to play tennis. So this was really easy, as I said, because there weren't too many people. We were just picking 2 from 5. So the answer to our question is 10. But of course, we want a quicker way to be able to do that rather than just to come up with all of these off the top of our head. So we can do something similar to what we did when we were calculating factorials. So if I need to pick 2 of these people, I can pick 5. There are 5 choices for the first person in the team and 4 choices for the second in the team. Now, if I multiply these together 5 times 4, I don't get 10, I get 20. So I actually have to divide by 2 here to find the number of combinations. So the reason I have to divide by 2 is so I'm not double counting. You see, I don't want to calculate Aaron and Brad as a different team from Brad and Aaron. It doesn't matter the order. It doesn't matter who I pick first and who I pick second. That's why I divided by 2, so I'm not double counting. I don't want to calculate Brad and Ethan twice. So this is how I could get the answer: 5 times 4 divided by 2. But even that requires, too much lateral thinking for a lot of us. We want an easier way. We want a formula. So what we can do is this. I can write times 3 times 2 times 1 on the top, as long as I also do that on the bottom. So note this here, 5 times 4 times 3 times 2 times 1, is 5 factorial. This here is 3 factorial. And 2 can be written as 2 factorial. So another way, a formula I could have used to calculate the 10 combinations here is 5 factorial over 2 factorial, 3 factorial. And you probably noticed something about these numbers. This was the number I had to choose from. This was the number that I was picking. And this number here is just 5 minus 2. And that helps us come up with the formula for NCR. So if I have N objects and I pick R, the formula is, just like I did in that example, the number I'm choosing from goes on top. The number that I'm actually picking is on the bottom. And then the difference between the 2 is on the bottom as well. This is the formula for NCR. So just so you're aware, in case it comes up, sometimes this notation is written. It doesn't really matter which one. So I could have used this formula to come up with the 10 combinations. So I'll tell you at this point, if you didn't quite understand how I came up with the formula, that's okay. It's not the end of the world. I just thought you might be more likely to remember it and understand it if you knew why the formula worked. But this is how we calculate the number of ways I can pick R objects from a group of N. Once you know that, it's really simple. So let's look at a few examples. So let's look at this first question here. Pizza shop has a choice of 12 toppings. Customers must pick 3 for their pizza. How many ways can this be done? Well, that's really simple. What we're doing is we have 12 possibilities and we're choosing 3 of those. Now, all you need to do is put this on your calculator. So on the graphics calculator, you write 12, then you go to math pick the NCR button, and then 3. So your calculator will use the formula, so you don't need to. It is 12 factorial over 3 factorial times 9 factorial. That's how your calculator gets the answer, but you just need to put that straight in your calculator, because there were 12 to choose from, and we're picking 3. So if you put that on your calculator, you get 220. There are 220 different ways for me to pick them. So note here, this isn't a probability question. I never mentioned probability. That's why my answer isn't between 0 and 1. How many? The answer should be a whole number. So let's look at this one here. Maris, 4 of the 8 houses are picked to participate in a charity event. How many ways can this be done? So once again, I want to illustrate, this is just a quick way of counting them. There are heaps of ways we could do it. We could have Darlinghurst, Hayden, Mark and Lavala picked. We could have Darlinghurst, Crispin, Conway, and Patrick picked. We could have, these are just 2 of the many possibilities. We don't want to go through and count them all. That would take too long. Instead, we're going to use combinations, and it's really easy. There are 8 things we're choosing from. We're choosing 4 of them. So all I need to do is put on my calculator 8C4. So if you let your calculator do the work, you get 70. There are 70 of these little combinations that I could pick. All right, now we're just going to do a quick question in which we find the value of n in NCR. So this question here says if NC2 is equal to 66, what's the value of n? So we're saying if I have a group of objects and I pick 2 of them, there's 66 ways to do this. How many must there be in the group of objects? So we're going to use the definition, the formula for NCR. So remember, for NCR, it's n factorial over r factorial times n minus r factorial. So here, n we don't know, but r we know is 2. So I'm going to rub out r and replace it with 2. So let's see how I can simplify this. So note, n factorial, we know, is just 1 times 2 times 3 all the way up to n. We know n minus 2 factorial, well, that's the same thing, except I stop at n minus 2. So n factorial would also have this. I just have n minus 2 and then n minus 1 before getting to n. So, n factorial over n minus 2 factorial would be this. I can cross out this on the top and the bottom. I'm just left with n minus 1 times n. So this thing here, I just figured out this part is equal to n minus 1 times n. So this is what NC2 equals, n minus 1 times n over 2. So to find what n is, I just solve this equation. N minus 1 times n over 2 is equal to 66. Timesing each side by 2, I get this. So what I'm looking for is a number times the previous number gives 132. So I've just got to find 2 consecutive numbers that multiplies to 132. So hopefully you know off the top of your head that would be 12 and 11. N would be 12. If I can't figure out that it's 12 and 11 off the top of my head, I would have to use quadratics. So I would just go n squared minus n equals 132. Subtract 132 from both sides. And then I just use the quadratic formula. Because n has to be positive, then n would be 12. If I use the quadratic formula, I'd get 2 solutions. I'd get 12 and negative 11, but I only include the positive solution because n has to be positive. It's a number of something. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.